Welcome to this session on Guardian Workflow.
Hi everybody, thank you for having me. Today I'm going to talk about the Guardian Workflow, which is a really fancy way to describe a generalized approach that we've taken for integrating Glacier into our digital repository. Our repository is a Samvera application, however, we sought to create an approach that it doesn't have to be Samvera, it doesn't have to be Fedora, it just has to support a Ruby-based workflow to get into Glacier. So in order to gatekeep myself up front, I'm just going to go through a couple of Glacier terms that I'll be throwing around during this session. We have, that's right. Sorry, I have my notes over here and this other screen, so we can bounce around a lot. There are regions. This refers to the physical region where the Glacier storage location is. You can see some examples here. I'm not going to get into the specifics of cost and transfer speed here. There are pluses and minuses to each individual location that you select and specify for your account. Amazon has some pretty solid documentation on their online dashboard for figuring out what's best for you based on your physical location. So there is a strategy to what you decide here. There are also vaults. This is Glacier's concept of grouping things. You can think of this similar to S3 buckets or any other grouping mechanism. There's a limit of 1,000 vaults per account per region, and this is obviously in place to make sure that you don't put all of your digital assets in one physical backup location, that if God forbid something happens, it's a problem. And then we've got archives. These are the discrete, immutable units of data that are stored within a vault. These can be individual files, however, it's recommended that you group files and compress them in something like tar or zip in order to keep your costs for transfer down. There are some space limits that I'm putting up here. I hope that you don't have any one individual file that's over 100 terabytes, in which case I don't know if anyone can help you. But you can use something called multi-chunk transfer for objects that are over 4 gigabytes in size, which I'll get into a little more detail in a little bit. Each archive is assigned a unique identifier within Glacier, and that's what you would use to call that archive back down if you want to download it again. And you can also associate one unique piece of metadata with that you supply at a time, which it's optional, but it's recommended if you want to be able to make sense of the inventory of your vault, because the identifiers are completely opaque. And then we've got inventories. And these are essentially a manifest of all of the archives in a vault, including all of the metadata associated with each archive. It's available for download as JSON or a CSV file. You can get a list of all of the vaults in your Glacier account in an instant, but inventories are called down as an asynchronous job, so you initiate an inventory retrieval job, and in about 3 hours you have your inventory, and it has everything that's in that vault. Then we developed some best practices and found some other best practices around this that we've put into place. For one thing, it's wise to record your archive metadata internally somewhere, like a database or something. It's preserved and available in the inventories. However, as I mentioned, you get everything and it takes a while to get it. So if you want to be able to just call down an individual archive relatively quickly, it makes good sense to record that information internally. So you just have a list of your archive IDs and descriptions. Also, Glacier does not dedupe processes. So if I call down an archive and you are in my organization, you call down the archive a little later, Glacier doesn't make sense of like, oh, 2 people on the same account want the same thing, I'm just going to call it down once and everyone's happy. It will just initiate multiple jobs. And this makes sense based on the way that Glacier operates with asynchronicity. You call down something for download and it's available on nearline storage from Amazon for 24 hours for you to get, at which point it then goes away and goes back into Glacier. So if you don't get it, you have to call it down again, spend more money, wait more time. So it makes a certain degree of sense, but generally speaking, if you're in the same organization, calling down data from Glacier, there should be a coordinated effort there. And then there's the principle of only request what you can retrieve. So as I mentioned, it goes away after 24 hours. So you want to factor in, like in the 24-hour period, what can our network support for transfer down, and how much storage do we have to keep the stuff that we're receiving. And then with that in mind, I developed a gem at Penn called Stronghold. This is a Stronghold from a tabletop game I've been playing recently. I went to Gen Con, a tabletop con over the summer, and so naturally I could not do that. I'm going to just mention a little bit here. This gem is at its heart a wrapper for the Fog Gems Glacier functionality, and with some best practices taken into consideration. For one, it has a test suite, which the Fog mock test suite for the Fog gem does not have for Glacier. You literally get a not implemented error if you try to do it, which is one of the meanest error messages I've seen ever. So I extended a Stanford-developed application called IceMelt, which acts as a false Glacier instance, and was able to flesh out a pretty robust test suite from there. It also checks for existing retrieval jobs before it initiates a transfer. And in the event that a job exists for something you're trying to call down, it will return that job's status as opposed to initiating a new job. So you'll get something like, this job is in process, this job has succeeded, or has failed. And it won't duplicate jobs. And likewise, in the event of transfer into Glacier, it returns the archive ID and associated metadata that you've assigned to it. You can do anything you want with it. You can put it into a database, key value store, text file, or just ignore it completely because you can listen to my best practices, which is fine. And if you look at the usage, oh no. Oh, I guess I can do this. Just want to go to thing. Just want to go here. Okay. Just want to go here. So if we look at the usage, you can pass credentials either as environment variables or a hash at runtime. And this is an example of how to instantiate, how to call down a vault inventory, and then just iteratively check and see if it's succeeded, and download it once it's available. Getting an archive, initializing transfer is also that easy. It's intended to be incredibly intuitive and easy, so that everybody doesn't have to suffer through muddling through various workflows and documentations. No shade, the Fog Glacier documentation isn't fantastic. The Glacier documentation for interfacing with the API with Ruby, I don't know where it is, I couldn't find it. So in an effort to keep people from, so much Stack Overflow, this is what we're doing. Okay, oh, it's gonna take me back to the beginning. And so once we have this gem, I was like, great. How do we implement this in our architecture, in our ecosystem? Because what's great about a generalized approach is you're not beholden to something greater like Sandera or Fedora, but there's not necessarily a natural integration point with your systems. So with that in mind, I consulted with some developers on my team on what this should look like, and I developed Guardian. In its prototyping stage, we were calling it Star-Lord. I don't remember why, I really wish I did, but I do remember in the end it was being too silly, and so we settled on Guardian, which is much less silly, if you ask me. So if this has two components. There's Guardian and Guardian Manifest. These are a set of Ruby-based workflows that funnel our objects into Glacier, record the metadata in a local database, and take a manifest input to orchestrate these jobs. I'm not going to go over what each of the pieces of information in the manifest represents because the readmes for these scripts hopefully do a decent job of it. They're linked specifically here in the slides. But if you're interested, I encourage you to go have a look. For the purpose of this presentation, they simply contain all of the information necessary to assemble zip archives and transfer them into Glacier and record the metadata back down. Manifests are available in two formats. There's the YAML manifest, which records all the information Guardian needs and then uses the Guardian manifest workflow to create a CSV that's then used to generate each archive's individual transfer manifest. And I'll get into why this is so complicated, I promise. And then there's the CSV manifest, which it looks horrible on the slide. Don't worry, it's much nicer in Excel. Maybe that's the first time anyone's ever said that. And this populates one row per archive with information for its individual manifest. Now, you may be wondering what this is about and why we're doing it this way, and that's because we're utilizing something called the To-Do Runner gem. This is a gem that was developed by my colleague Doug Emery at my institution. It makes a lightweight DSL available for orchestrating tasks using to-do files, which are YAML files, and they end up looking something like this that we see on the slide here. And what you're seeing is essentially we have the ability to take an individual YAML manifest representing all of the information for transfer, convert that to a CSV, one row per archive, and then make a bunch of individual YAML to-do files, one per archive for transfer. And then it kicks off the transfer process with each of the individual to-do files queued up, and then just basically going from the repository into Glacier and recording the metadata back down into our local database. And this is the metadata, this is what it looks like. So there's your opaque identifier for the archive ID, and then for our associated metadata, we're passing a JSON blob with information kind of like this. We select a JSON because we don't really know how much information we're going to want to associate with each archive, and the good thing about JSON is you can just keep cramming stuff in there. I mean, with purpose, but it's flexible.
On that alternative ID, is there a limit to how large that can get in Glacier?
The metadata?
Yes.
I'm certain there is, but I haven't found it. Like, I'm guessing if I, crammed everything in the internet in it, it'd probably stop me, but, yeah, I mean, I would assume that you could probably keep a lot of information in there. And I mean, this is essentially one of our alternative IDs. We have what's called a directive name, and then we have our ARC identifiers that we're using for our stateful identifiers. So this is a way that we can kind of keep track of what exactly this archive is. And then it's just a matter of like which application does it belong to and which user-initiated transfer. Thank you. As I mentioned, if this workflow seems a little bit complicated, perhaps overly so, I can eliminate some of our considerations. For one, I wanted to use the to-do runner gem to orchestrate these tasks because the way that it operates is that it changes the file name of each of the YAML manifests once jobs are kicked off. That this job is in process, and it indicates which individual archives succeeded in their job, whatever it may be, that in this case getting up to Glacier, which ones failed, and in the event that there's a catastrophic failure that knocks the whole process over, it indicates which files were queued up for the process and never got touched. So that was handy. I also wanted to design a workflow that could support multiple applications. Oh God, I have to go back into the browser. And we have another application at our organization that is going to be extending this soon, and like literally the hope is that the other developer simply has to flesh out this particular case statement with assembly of an uncompressed archive, at which point then Guardian knows what to do to compress and transfer it and record the metadata. You could say I left a very helpful comment there for that. And finally, I also wanted to preserve the ability for staff to create manifests for Glacier transfer. I consider making anybody write a YAML file with a lot of information by hand, particularly if they don't work with YAML very often. One of the cruelest things I could do as a developer. And if I'm mad at someone, that's one thing, but in any case, our metadata staff are really comfortable with spreadsheets, and they use it for a lot of their different workflows. So the idea that we can take a CSV file and do stuff with it is pretty valuable. Also, we have that CSV file, and they can extend the contents of that to indicate things like transfer status or whatever, and use that to generate reports in their departments. Now, there were some challenges along the way. We use Git extension called GitAnnex to calculate remote checksums of our files in our remote storage, keep track of their health. And while it can interface with Glacier, it relies on synchronicity. And the fact that Glacier is asynchronous, that you can call up an inventory that's 12 hours behind, and even then in its documentation, you're not necessarily going to see everything completely up to date. You essentially have to tell GitAnnex to blindly trust what it cannot see in Glacier as being healthy and valid and available. And so that's why it really didn't have a natural integration endpoint in our repository as we had initially hoped when we were adopting Annex. We also ended up having to devote quite a lot of time to production DevOps deployment strategy. We had using Docker Swarm or a Docker Swarm shop. And we had a fair number of really sensitive secrets that we needed to use, like AWS keys, SSH keys to get to remote servers. The code is pretty much ready to deploy 3 months before we deployed it because of this, but it's time well spent because we have a really pretty robust and secure strategy in place at this point. And then finally, there's just the quirks of interfacing with Glacier. We have seen, as we transfer larger and larger archives, we're seeing connection timeouts that we had to really tweak the connection settings when we talk to Glacier. The irony of Glacier timing out for long, slow transfers was not lost on anyone on our team. And then there's I/O concerns, so we need to, as we get larger and larger archives, as I mentioned, you need to sort of chunk up larger files, and so we need to be smart about what we load into memory that we then transfer to Glacier, because there is stuff sitting on the metal at some point, proverbial metal. And then just, we're probably going to see some other growing pains along the way. Multi-part chunk sizes per individual transfer are limited to 10,000 per archive, so we're probably going to want to make that highly configurable based on the size of objects that we have. And so I'm just going to talk briefly about some strategies that we developed for disaster recovery at a mass scale. This first one's probably a no-brainer, but once you select your region, like the United States or Pacific Asia or what have you, pick a sub-region that is not close to you at all. We seriously had discussions like when we were deciding on our region. It's okay, under the United States, is Ohio far enough away from Philly? Like, definitely not West Virginia. Like, is Portland, Oregon? Like, is that, so, it's kind of silly to consider, but it is a consideration to have. Likewise, depending on policies for storage in your country, there may be regions where you're legally unable to store things.
Can you support sending to 2 different regions simultaneously?
Yeah, you would want to be able to specify that at runtime, which Stronghold allows in the configuration convention. And then likewise, to that end, you may want to create a list of archives for prioritized retrieval in the event of mass data recovery. It's going to be intentionally vague about what would prioritization be, because it's going to be different for every institution. But you could see the value in, we've lost everything, let's get the things that are at the most risk back, or the most popular, or what have you. At Penn, we're in the process of creating a metadata-only archive, which is all of the descriptive metadata in something like XML for everything we have in our repository. The idea being this will be smaller to get, and we can download it easily and simply index it, hopefully, and make it available online. Like, this is what we have, and we're in the process of getting it back, as opposed to just wait forever and be dead in the water until everything is back. And then we are dividing the vaults into application-specific vaults. As I mentioned, we have that limitation of 1,000 per account per region, and so we're doing it by application because it makes some common sense within our organization, and we have several applications that are necessarily going to combine later on. One right now is going to combine with our repository later on and just use its Glacier transfer as the on-ramp into Glacier, at which point we can hopefully take the deprecated applications software vault and just delete it, hopefully without ever having to go into it. And then next steps, I'm finalizing the test suite and confirming generalizability with Stronghold Gem and the Guardian workflow with another application. Once that's ready, which should be in a couple of weeks, I would imagine, I'll be pushing that gem to rubygems.org as its product owner, and hopefully this becomes something that folks in the community can use. I'm really interested in others kicking the tires on this, filing issues for additional flexibility that's needed. Pull requests are, of course, welcome, but even just raw feedback is really useful. And that's it. So.
Are there any questions?
So you had mentioned keeping secrets safe. Can you touch on how you did that?
Sure. So we're using Docker Swarm, as I mentioned, which allows us to use Docker configs, which is slightly different from the Docker config command. So you can read in configuration files. You can also use Docker secrets, and we're loading certain secrets in via an encryption method that we have on an internal development deployment server. That's for the SSH configs. And then the other secrets are being fed in as external files that are also similarly encrypted. This allows us to, essentially, there's only a secret inside the container that if you get into the container, go to where the secrets are available and are able to read that file, at which point we probably just need to power down that server because no one's supposed to be connected to it. Yes.
One of the things we've been thinking about with Glacier is how much we trust it. And our current plan is to set up a workflow to retrieve things periodically and check something. How much do you trust Glacier, or are you doing checksuming independently of what they do?
So the question of how much do we trust Glacier, and are we doing any sort of periodic health checks? We have done health checks in terms of when we're establishing this. Are we creating archives that are meaningful and available and everything we expect? Because we are also the archives are the Git Annex version repositories for each object, so we need to make sure, can we make sense of this with or without Git Annex if it's not available? We saw pretty good results, and Git Annex kind of takes care of making sure that we are able to see whether or not checksums have changed. We don't really trust Glacier all that much. It's intended as our third copy backup, so you know, there would be sort of more local backup recovery, and then it's sort of a dark metaphor, but I refer to this as the smoking crater in the earth backup, like the data center is a smoking crater in the earth, and we need to get everything back. And hopefully it's right, but we are going to be building workflows in to periodically just check a few files, a few archives to make sure that they are okay. Any other questions?
Okay.
Oh,
I'll use the mic this time.
Oh, yeah.
Thank you. You mentioned Git Annex and its opacity with checksums in Glacier. And it sounds like you're doing a representative sample of your archives. And so that's aside from Git Annex?
Correct, yeah. It doesn't, I mean, it can interface with Glacier, but there were several limitations, including that it really can't. So Git Annex, if you want to modify or delete a file locally, it needs to be able to essentially validate that that file is available at one of, or two, or whatever you configure, remote storage locations. Glacier is one of them, but you need to pass literally a trust Glacier flag in order for it to count as, yes, it's valid in Glacier. So it just didn't really make a lot of sense, and it's completely outside of Git Annex. In addition to that, probably because of the way that, you know, asynchronicity and synchronicity aren't meshing, there is a specific library that Git Annex needs to use to interface with Glacier, which is okay, but it's maintained by one person, and, you know, for obvious reasons, it's less than ideal.
Thank you.
Any other questions? Good. Thank you very much.
Thank you very much.
Good job.